Hello, so for the rest of this unit we're going to be talking about errors involved in sampling measurements from a population. But for just now I have a couple of things to say about errors in measurement when we're carrying out experiments. So I'd like you to cast your mind back to the very first lab we ever did when we were validating our pipettes and our pipetting. So this brings into play the idea of precision versus accuracy in measurement. So do you remember, so we were checking our pipette, so pipette 1 ml of water, and that should weigh by definition exactly 1 gram. So you did that, and so you might have got, so with pipette 1, maybe you got 1.000 grams, 1.002 grams, 9.999 grams, 1.001 grams, 9.998 grams, something like that. So there the mean is 1.000 grams, and they're all fairly close together. How about and then with pipette 2, let's imagine you got 1.052 grams, 950 grams, 780 grams, I don't know, I'm just making this up, 1.230 grams, 9.857 grams. Anyway, so there the mean is, okay, silly me, so this should be, I'm just going away and try to work out the average. This should be 0.995, obviously 0.978. Sorry guys. And and obviously this should also be 0.99, 0.998. Apologies. My point stands. So here I've worked out the mean, it's 1.047, so that's damn near to what it should be, of exactly 1 gram. And then pipette 3, how about if we had 1.115, 1.117, 1.113, 1.116, something like that. So there the mean is 1.115, and these are all very close together, but the answer is wrong. The answer should be 1 gram, and it's on average 1.115 gram. So this is both precise and accurate. Okay, this we have a larger spread, so it's not precise, but it's quite accurate. So the average weight we get is pretty good, and this is this is precise. They're all quite the same, but it's not accurate. So that's showing you by examples what I mean by precision and accuracy in measurement. That's just a little example. And another thing I want to tell you about is there are errors inherent in the equipment we use. So for example, some of the balances we have in the lab, you might see something like this, so it's weighing in grams, so it could say 1.034, and then the last digit is hashed out. I think that's how many decimal places they can do. And so that tells us not to trust this number. So it's unable to measure accurately that to that level of precision. Okay, so those are just a couple of thoughts which we've already talked about in the practical lab, and of course this relates to the ideas we were talking about last week about standard deviation of a sample. So this will have a larger standard deviation than the other ones.